And last time I asked you to work on this formula and to look up if you can find any simpler expression for this triple cross product. So, has anybody found? Has anybody searched?
I searched, but I didn't know to implement Google.
Okay, we can show you how to search. Because this is just another instance when I don't want you to focus on details of the formula. Like doing homework, I don't want you to suffer for hours computing things by hand, right? Just do the Wolfram alpha. In this case, I failed to ask Wolfram alpha, well, to get any decent information from Wolfram alpha about this formula. It didn't tell me how to simplify it. So what I did is all right. So I asked for vector calculus. And you see the first suggestion is identities. And the first link is to Wikipedia. And what it gives you basically is all kind of concepts that you will see in other courses, including the, well, we will see this nabla very, very soon. But you see vector product, dot product, all the properties of those operations, and some identities. And this one, no, not this one, next one, is exactly what I was asking for. Right, so it says that for any 4 vectors, the cross product with another cross product is equal to something. So what is it exactly? Can you interpret that formula, please, for me, so that I can write it properly?
This is
So what is it saying there? Do you know what that is? Do you recognize? A dot B cross D. What is that?
It's just a dot product and then a vector product.
Yes. So you take 2 vectors, you do dot product, right? And the result is a number, right? And then you take that number, take a vector, and do vector product. Is that what it is? How can you do a vector product with a number? Can you?
you do the vector product and then dot product.
So you do the vector product first, resulting in a vector. And then you do dot product with another vector. So only one way makes sense. That's why we don't have brackets here. But one should understand how to read this formula properly. So it is a vector product dotted with another vector. And can you recognize that as something else we've seen before? Because it has a different name. It is the volume. So it is the volume on those 3 vectors, A, B, D. So if I want to use those notations A, B, C, D. So this is A, this is B, this is C, this is D. So what I need is volume on ABD. Volume on D and A and J. Isn't that good? Volume on velocity, acceleration, and jerk. It's hidden from you, but it's there. It's what we got from physics point of view, the volume in numerator. But now that has to be... So what is that? What is this C doing there? Is that a dot product or what is it? So yes, indeed, this is a scalar, right? After you vector product and dot product, you get a scalar, a number, and you multiply that number by that vector. So that volume as a number, right, needs to be multiplied by that vector C. C means V. Okay, that's the first summand, and then minus. So what else do we have there? Volume again, right? Volume on A, B, and C. Now we have V, A, and V. And that volume needs to be multiplied by jerk. And we have to take magnitude of that difference. And that's all we need from Wikipedia. So that needs to be divided by the same V cross A squared and the speed. Now, are we getting closer to that formula? Is there anything we can simplify here? The second term is 0. Volume on velocity, acceleration, and velocity. And so that is 0. So the only remaining part is this. Magnitude of volume on V, A, and J multiplied by velocity and divided by now how do we take the magnitude of that vector? Well, this is a scalar, right? So that scalar can be pulled out of the quantity if it is positive. Right. So volume on V, A, and J multiplied by the magnitude of V itself, by the speed, and divided by square root of that cross product and the speed again. And of course the speed cancels. And what we get is something that looks differently, right? Volume on V, A, and J divided by the square of that cross product.